if your question is related with other department, I can talk to the concerned department and I can come back to you later. So firstly, what is testing? So testing can be performed on part or product to verify it functions as per the design. So it's very simple. So we are going to perform the test to check on part or product to verify it functions as per the design or not. So next, what are the types of testing? We have 4 types of testing. First one, functional test, performance test, endurance test, and durability test. What is functional test? Functional test is a test to check the function of part or product. So firstly, we need to check the function of the part or product. So let's consider pen as an example here. So what is the function of the pen? The pen has to write, right? So first we have to check the function of the part. The second one is performance test. Performance test is a test to check the performance of part or product. So again, we will consider pen as an example. So here we need to check the performance of the pen. So what are the performance of the pen? I can say the pen has to write smoothly. There should not be any ups and downs while you're writing using pen. And it has to write in the proper color. So these are some performance of the pen. So next test is endurance test. If you look the word endurance and durability, it looks similar, but technically speaking, it's different. First, what is endurance test? Endurance test is a test to check the part or product until its defined cycle. So what do you mean by defined cycle? As you know, each and every part or product have its own warranty period. Right? So we need to check the part or product that it's not going to fail until it's complete its warranty period. So here the defined cycle is a warranty period. The final testing is durability testing. So durability test is a test to check the part or product until it fails. So same endurance test, we are going to continue until the part fails, so that we can find out what is the life cycle of the part or product. So these are the types of testing. The first technical topic which we are going to discuss today is engine testing. What is engine testing? The purpose of testing an internal combustion engine is to determine the information which cannot be obtained by the design calculation, to confirm the data used in design, and to validate the data of which may be doubtful. Finally, the end customer gets satisfied with the performance of the engine. In simple words, I can say that the engine has to be tested to determine the information which cannot be obtained by the design calculation. As you know that engine is a mechanical component. Okay, so we need to understand how the engine behaves at different load and RPM conditions. To measure, so to understand the behavior of engine, we need to measure the parameters in engine. So here is where instrumentation comes into the picture. To measure the parameters, we need instruments and sensors. Okay, so what are the types of engine testing? Engine testing includes performance test, which comes with full and partial throttle performance, oil consumption test, emission test, endurance test, and durability test. First, let me give you an overview what we do in engine testing. The engine totally tested for 1000 hours. So in every 100 hours, we will do the service. In the service, we used to change the lubricants, engine oil, fire filters and oil filters, and general checkup. Once the service is done, we will proceed with the performance test, which is full throttle performance test. What is full throttle performance test? So we are going to run the engine with full throttle and by varying the RPM from higher RPM to lower RPM. So in each RPMs, we are going to measure the parameters. So finally, using those parameters, we are going to derive the power curve, find out the engine performance. So once the performance test is completed, we are going to proceed with the oil consumption test. What is oil consumption test? So we need to find out how much oil is consumed by the engine. So for this test, we have to run the engine continuously for 8 hours with full RPM and with full torque condition. So once this oil consumption test is completed, so we will go with the endurance test. What is endurance test? So we do have a derived duty cycle to test the engine. Okay. So we do have a defined duty cycle to test the engine. So this endurance test will be continued for 92 hours continuously to find out how the engine is behaving or how the engine is performing. So these tests will be repeated in every 100 hours. In case if the engine got failed in between, just we will remove the engine from the test bed and we will send to the concerned department for teardown analysis. So this is about engine testing. So next we are going to talk about what are the instruments we used in engine testing. When we talk about instrumentation, I can say it's categorized into three systems. The first one is measurement system. Second one is data acquisition system. The final part is data analysis. What is measurement system? As I told you before, engine is a mechanical device. So where we need to find out the parameters in the engine. Okay? To find out the parameters, we need sensors. So these are the sensors we used in engine testing to measure the engine parameters. RTD and thermocouple to measure the temperature, pressure transducer to measure the pressure, accelerometer to measure the acceleration or vibration, load cell to measure the load, RPM sensor to measure the RPM or rotation, microphones is used to measure the acoustics related parameters, or the sound pressure related data. Finally, the strain gauge is used to measure the strain values. Okay, so it's very important to choose the right sensor for the right application. So we have to make sure that all the sensors has gone through periodic calibration so that we can make sure that the data which we are going to collect is exactly used. So in the measurement system, we have installed all the sensors and engine, right? So next system is data acquisition system. What do you mean by data acquisition system? I can say it's a device to store the data and view the data as well. Okay. So I can tell you the basic block diagram of data acquisition system. So transducer, right? The output, we have a transducer. The output of the transducer will send to the signal conditioning unit. So from the signal conditioning unit, it goes to the multiplex. So from there, it goes to the analog to digital converter. Finally, you can view the data in the display. So as you know that most of our sensors produces analog output. Okay. Firstly, we need to convert that analog output to digital for the post-processing. So basically, if you see this data acquisition system is a device which consists of so many layers. So each layers can be, based on the sensor selection, you can select the layers as well. Okay? We do have a dedicated bridge layers to measure the strain values. And we do have a high-speed layers to measure the high sensitivity data, which comes from accelerometer, strain gauge, and microphones. And we do have a low channel speed data to measure the data comes from RTD, thermocouple, and pressure transducer. And we do have a dedication data acquisition software for this device where we need to do the configuration of each and every sensor. And it's very important, you should not do any mistake while you're doing the channel configuration. So you should feed the information like sensitivity of the sensor, sampling rate, frequency, range, and excitation source, and much more. So if you do any mistakes just while you're doing the configuration of the sensors, so whatever data which you're going to collect will be completely missed. Okay, so these are the two data systems we used in engine testing. One is dynamic controls, other one is AVM. So these are the two brands we use in engine testing. Okay, so now we have collected the data in the data acquisition system. Now with the data analysis part, we have to put those data to do the post-processing. So data analysis software is very powerful software. We don't want to do any coding or programming in this software. Okay? It's a kind of pre-developed software where I think most of your people know about MATLAB Simulink, right? So in MATLAB Simulink, we have a library And inside the library, you guys have many blocks, right? It's a kind of block diagram where you guys have to plug and play using those block diagrams to find out the exact result. I can say that you guys should have a strong knowledge in digital signal processing and mathematics to work with data analysis software. So in engine testing, the softwares which we use is Visu and Inca. So Visu was developed by Delphi TVS and Inca was developed by Bosch. So based on the supplier, we will select the softwares. So these are very powerful software where you can control the complete behavior of the engine by using this software. I can say we can do engine calibration, fuel mapping, and much more using this software. Okay. So now we are going to talk about the sensors used in engine testing. So firstly, RTD and thermocouple. As I told you before, we use RTD and thermocouple for temperature measurement. First, what is RTD? RTD is resistance temperature detector, which used to measure the temperature. There are many types of RTD. We have nickel type, we have copper type, we have tungsten type, and we have platinum type. The most common type used in industry is a platinum type. If you see the construction of RTD, we have a thin platinum wire surrounded with the glass core. Okay? So when this copper wire is exposed to the temperature, the resistance will get varied and we will get the output, electrical output accordingly. So the main advantage of RTD is it's a linear device where the readings is going, whatever reading which you're going to take using RTD is stable for a long time. And I can say the measurement range of RTD is minus 250 degrees Celsius to 850 degrees Celsius. Beyond that, we cannot use RTD. Okay. Next is thermocouple. Thermocouple is a sensor to use to measure the temperature as well. Okay. But the concept behind thermocouple is different compared with RTD. So in thermocouple, two dissimilar materials is twisted together and welded as well. When this point is exposed to temperature, we get the electrical output accordingly. Similar to RTD, in thermocouple also, we do have many types like J type, T type, K type, E type, S, N, and B, C type. Okay, J, T, K. These are the types was commonly used in industry. The reason is the maintenance of these sensors is very cheaper and cost effective as well. The main drawback of thermocouple is this device is not linear. I can say the output which produced by thermocouple, it's very less. It's very, very low. I can say it's even in the millivolt. Okay, so because of that, it's not linear. So next sensor which we are going to talk about is accelerometer. What is accelerometer? Accelerometer is a sensor to measure the acceleration or vibration. We have different technologies involved in accelerometer. We have piezoelectric type, piezoresistive type, and MEMS type. So these are the common types which we use in industry. So, and there are two types of accelerometers, which is uniaxial and triaxial. So from the word uniaxial, you can understand that they are going to use this sensor to measure the acceleration in single direction. Whereas the triaxial accelerometer can be used to measure the acceleration in three different directions at a time, which is X longitudinal direction, Y lateral direction, and Z vertical direction. And this sensor is very, very sensitive and it's very, very expensive too. And expensive too. I can say, what is the cost of this accelerometer? One triaxial accelerometer cost comes around 20 to 25 lakhs. Okay. So the handling of these sensors should be very, very careful. Yeah. So next sensor is pressure transducer. So what is the use of pressure transducer? This is a sensor to measure the pressure. Based on the applied pressure to the sensor, the diaphragm will get varied and we will get the electrical output accordingly. So in industrial perspective, we use two terminologies. One is pressure sensor, other one is pressure transducer. If you see technically, both look similar, but in industrial perspective, it's different. So we used to call it as pressure sensor when the output is 4 to 20 milliamps. So we used to call it as pressure transducer when the output is purely voltage related. Again, in this transducer also we have many technologies: piezoelectric, piezoresistive, piezocapacitive. And the next sensor we are going to see is RPM sensor. What is RPM sensor? It's a sensor used to measure the rotation or the RPM, speed. So there are two types of RPM sensor. One is magnetic type, other one is optical type. So what is magnetic type? Okay, we have a probe surrounded with a magnetic coil, and it's exposed. The probe is exposed outside. We do have a two-third wheel. Say for example, in the two-third wheel, if we have 60 T's, we can do the program that 60 T is equal to 1 rotation. So whenever the two-third wheel rotates 60 T, it will give you 1 pulse as the output. Similarly, the optical type, instead of probe, we use a light rays. Okay? So we use a light rays and we use the reflecting sticker. Whenever the reflecting sticker is going to cut that light rays, it gives pulse output, gives you 1 pulse output. And the next sensor which I'm going to talk about is microphone. So microphone is a sensor used to measure the acoustic data or sound pressure data. Okay. Again, it has two technologies. One is piezoelectric and piezoresistive. When the microphone is subjected to the sound pressure, based on the sound pressure, we will get the output accordingly. Okay. So inside the microphone, we have the diaphragm. So based on the sound pressure reaches the diaphragm, we get vibrates, and we will get the electrical output accordingly. The final sensor which we are going to talk about is strain gauge. It's a very, very interesting field to work with. You know, I can say people should have more patience to work with strain gauge. What is strain gauge? When the load is applied to the strain gauge, the resistance will get varied and we will get the electrical output. So here inside this strain gauge, we do have a foil. This foil is going to act as a resistance. So based on the applied load, the resistance will get varied and we will get the output. So similar to accelerometer, here also we do have two types of strain gauge: linear strain gauge and rosette strain gauge. So linear strain gauge, it's a single gauge where you can measure, where you can paste the strain gauge to measure the strain values in single direction. Whereas you can use the rosette strain gauge to measure the strain values in 3 different directions at a time. You can see the concept, the architect of the concept of rosette strain gauge is 3 linear strain gauge attached together, okay, so that you can measure the strain values in 3 directions at a time. And at the same time, you can use 4 linear strain gauge to convert into full bridge configuration, and you can use 2 linear strain gauge to convert into half bridge configuration. So based on the sensitivity of your data, based on your requirement, you can choose the bridge configuration. So this is a picture of strain gauge. Okay. So here I do have a video to show you how do we install the strain gauge. Okay. So installation of strain gauge is a big procedure. Okay. So we do have many steps to install the strain gauge, but this video is about 20 minutes. Maybe I can play this video at the end of the session. So now we will talk about what are the installation steps involved in strain. So first thing, we need to prepare the surface to install, to paste the strain gauge. So it's very, very careful to prepare. While you're preparing the surface, make sure that the surface is free from grease particles, oil particles, rust particles, and dust particles. Okay? So it should be completely cleaned and smooth before installation of strain gauge. Once the surface is prepared, so we need to do the marking. So we have to do the exact marking where we need to place the strain gauge. So once the marking is done, we need to bond the strain gauge. So bonding, while you're bonding the strain gauge, there should not be any ups and downs in the strain gauge. So because of that, if there is any ups and downs in the strain gauge, then the value which you are going to collect, data which you are going to collect will be completely pasted. So you should make sure that you have pasted the strain gauge in the exact marking. So once the bonding is done, you need to do the soldering and wiring based on the configuration you choose. So once the bonding and soldering and wiring is done, we need to protect the strain. So as I told you before, strain gauge is very, very sensitive sensor. I can say the thickness of the strain gauge is lesser than the paper. Okay, in case if you don't handle it carefully, the sensor will tear. So you should handling of strain gauge is very important. So once all the installation step is done, you have to protect the sensor so that you will not get any problem during your measurement. So to do all this installation, we do have a special tools and adhesives. Okay, so you have to use the proper tools and proper adhesive during the installation of strain gauge. So this is the picture of engine test bed. So you can see the engine is mounted in the test bed and it is coupled with the eddy current dynamometer. In engine test bed, we use eddy current dynamometer to apply load to the engine. Okay, so you can see many cables surrounded by the engine. So those are the sensor cables. So the sensor cables, the sensors are mounted and the cables is connected to the DAC system to measure the data. So these are the pictures of eddy current dynamometer and engine testing DAC system. So next technical topic, which we are going to discuss is vehicle testing. So in the previous topic, we have tested only the engine, right? But in the vehicle testing, we need to check the complete vehicle and its subcomponents as well. So what is the definition of vehicle testing? Vehicle testing is a test to complete vehicle components and system through a series of laboratory, virtual and real-world assessments to ensure the data is safe, reliable, and compliant with safety regulations. Okay. So what are the types of vehicle testing? We do have 4 types of vehicle testing: functional test, durability test, homologation test, and RLDA test. So for each and every test, we do have a dedicated department to work with. Okay. So what is the responsibility of functional test? So they will take care of the functional test of complete vehicle and their subcomponents. So in the durability test, they will check the complete vehicle durability based on the duty cycle. So next is the homologation test. So homologation test is a test, it's a purely certification related department, where this department will take care of the vehicle produced is as per the government norms and regulations. And the final testing is RLDA test. So this is the department I work with. It's very, very interesting department. And it's purely technical department where instrumentation comes into the picture. So what is RLDA? So RLDA stands for Road Load Data Acquisition. So RLDA is a study to find out the structural behavior of the vehicle and the subcomponents. So once the vehicle is designed by the design engineer, what they do, they will do the simulation test at their end to find out what are the critical structures in the vehicle. Once the simulation test is completed, they will come up with the results by stating that these are the critical structures in the vehicle which could potentially fail in the future. By keeping these data as input, we will do the instrumentation in the vehicle and we will take the vehicle to the public road and we will collect the real-time data in the vehicles and we will do the analysis. Say for example, if the warranty period of the vehicle is 1 lakh kilometers, it's not practically possible to check the complete vehicle for 1 lakh kilometers. Instead, what we do, we will collect the real-time data for 5,000 kilometers, say for example. Okay? So we will collect the real-time data for 5,000 kilometers. So using those data, we will extrapolate it until 1 lakh kilometers and we will derive the duty cycle. Once a duty cycle is derived, we will hand over that duty cycle to durability department. So where durability department will test the vehicle based on the duty cycle to find out the vehicle failures. The next step is using the strain values, we will do the damage calculation of the part or product. Okay. So using the damage calculation, we can calculate the life cycle of the part or product. So these are the activities. So this is about RLDA. So next, these are the sensors we used in RLDA. Again, similar to engine testing, we have measurement system, data acquisition system, and data analysis. Okay? So these are the sensors, DAC system, and the analysis software we use in vehicle testing. I hope we have seen all these sensors in the previous session. DAC system also, only the brand name is going to get varied, but the concept is same. Okay? And the data analysis software also, the brand is going to get varied, but the concept behind is same. So this is the DAC system we used for RLD, which is HVM SOMAT DAC system. As I told you, you can see in the DAC system, we have many layers. Okay. So based on the selection of sensors and the requirements, you can choose the layer, and you can keep on adding the layer until it completes its maximum limit. So with this, you can measure the GPS data and all kind of sensors data, etc. And this is the view inside the cabin. Okay, this is how it looks like while we're doing the measurement. This is how it looks like. Yeah. So the next thing is we are going to talk about the test track. So what is test track? So each and every car manufacturer have their own test track inside their premises. As I told you before, it's not possible to test all the prototype vehicles in the public roads. So we do have some restrictions in testing in public roads. So to avoid that, each and every car manufacturers have constructed the test track inside their premises. So in this test track, it consists of off-road patch, rough road patch, high-speed track, figure of 8, and much more. Okay, where they have simulated the public road condition inside the test track. So these are the types of test track. So you can see the cobblestone, pothole, articulation, high-speed track. So the upper picture shows you the test track road, and the below one is public road, so that you can get some understanding. Okay. So the third technical topic which we're going to discuss today is validation testing. What is validation testing? Validation testing is a testing, and it has a own independent procedure that are used together for checking the part or product, whether it meets its requirement, specification, and it fulfills the purpose. And it's a test to simulate the actual field condition inside the laboratory using test fixtures. So validation testing is a testing where we do have an independent procedure to check the part or product, and it's a kind of laboratory test where we are going to simulate the actual field condition inside the laboratory using test fixtures. There are two departments basically involved in validation testing. One is field validation, other one is part validation. What is field validation? So the role of field validation is to collect the data in the field, to collect the real-time data in the field, and using those data, they will do the analysis. So what part validation will do is they will get the real-time data from the field validation. So using those data, we will create the test fixture where we can simulate the actual field condition inside the laboratory. So here is the way automation team comes into the picture. We do have many sub-suppliers, automation sub-suppliers, where they can help us to develop the test fixture based on our requirement. Okay. In validation testing, we have different types of validation testing. One is functional test, performance test, endurance test, and durability test. Okay. So for each and every test, we do have a specification based on the part or product. So it has to fulfill during our testing. We have to make sure that the testing has been fulfilled as per the specification. So What are the instruments used in validation testing? So as in the previous topics, again, it has measurement system, data acquisition system, and data analysis part. And the sensors which we used in validation testing also same. And the data acquisition system, it's the same, but different brands. And the data analysis software we use same and different brands. Okay? So since we have discussed in the previous topics, I'm moving to the next slide. So these are the some test fixtures, photographs. Okay? So I have shown you the steering gear test fixture, how it looks like. Okay? So you can see it's a test fixture where we are going to fix the part and we are going to simulate the failures. Okay. So during this measurement, during this testing, we will, as I told you before, we will use to collect many parameters to find out how the part and product is behaving. Yeah. The final part of the technical topic is NVH, which is noise, vibration, and harshness. This is very, very interesting topic and very wide topic too. What is NVH? NVH is a study and modification of noise and vibration characteristics in the vehicle. Okay? We do have special equipments to measure the noise and vibration, but we don't have any measurement to measure the harshness in the vehicle. So normally there are two types of evaluation in the NVH. The first one is subjective evaluation. The second one is objective evaluation. What is subjective evaluation? Subjective evaluation is evaluation where we can decide we can get the result based on the people. You know, the most common method of subjective evaluation is jury method. So there will be a number of peoples where they can observe their the NVH parameter using their ears, and they can give the rating, subjective rating. So based on the subjective rating, we will conclude the results. Okay. Whereas objective evaluation is purely technical, where we need to use sensors and instruments to measure the data and do the post-processing to find out the exact result. So what is vibration? Vibration is an oscillation in a system, right? Vibration is nothing but an oscillation in a system. When the part is subject to vibration, it start moving from one direction and then it backs to the opposite direction, right? So it keeps doing continuously. So what is noise? Noise is a difference in sound pressure. So vibration is related with structural bone, whereas noise is related to air bone. So when we talk about NVH, it's very important to understand the basic mechanical elements. So what are the basic mechanical elements here? We have mass, we have spring, and damper. Right. First, let's talk about spring. In the real life, the springs are not linear, right? Springs are stiffness element used to store and release the potential energy, okay? So when the force is applied to the mass, the spring absorbs the potential energy or stores the potential energy from the mass and release it back to the mass again. And it keeps doing it forever, continuously, okay? Technically speaking, it's keep doing it forever. Whereas next is a damping element. Damper is the next element. So what is damper? Damper is used to dissipate the energy, okay? The construction of damper is like a cylinder. We have a cylinder, we have a piston. Below to that, we have the fluid. So when it is subjected to vibration, okay, what damper does, it absorbs the vibration from the spring and dissipates it in the form of heat energy. Okay. So it's very important to understand how the system behaves with damping element and without damping. Okay. First, let's talk about no damper. Okay. As I told you before, when the force is applied to the mass, the spring will absorb the potential. The spring will store the potential energy and release it back to the mass, right? So because of that, the amplitude is not going to reduce, okay? And it keeps doing it forever, so the amplitude is not going to reduce, okay? At the same time, if you see, At the same time, if you consider the system with spring and damper, you can see here, once the force is applied to the mass, the spring absorbs the potential energy, stores the potential energy from the mass, whereas the damping is going to absorb that vibration and it's going to dissipate in the form of heat energy. So because of that, you can see the amplitude is going to see that it starts with higher amplitude and it's getting reduced at one point of time. It comes back to the original position. So now we are going to compare these elements with the vehicle, right? So we have a body in the vehicle, right? That's called as mass. And the spring, we do have a spring in the vehicle, right? All the suspensions are spring in the vehicle. And we do have shock absorbers in the vehicle, which act as a damper. So these are the instruments we used in NVH testing. Sensors is accelerometers, microphones, and load cell. And DAC system is LMS SCADA access. And analysis software is LMS Tesla. Again, the concept is going to be same, while the brand is going to get different. Okay. So next is, what are the types of NVH testing? There are three types, okay? The first one is natural frequency analysis. What is natural frequency analysis? As you know that, each and every part of product have its own natural frequency. So we have to find out what is the natural frequency of the part. Now, we do have a testing called modal analysis to find out the natural frequency of the part. So what we do in the modal analysis, we use to fix as much as possible of many accelerometers in the part, and we are going to give the impact, okay, using impact hammer, nothing but a load, okay. So based on the load, we will collect the data. By using those data, we will derive the frequency of the part and product. I'm telling you very simply, but it's a very big process to do that. Okay. So next is transfer path analysis. What is transfer path analysis? In the vehicle, there are many vibrating sources, right? There are many vibrating sources. I can say engine is one of the main vibrating source, and the tire and the road condition is going to excite the vibrating source, and the proper imbalance of propeller or drive shaft can create the vibration in the vehicle, and the exhaust system can cause the vibration because of flow of gases. Okay, so engine vibrates because of firing, right? We have a firing inside the engine because of the engine starts vibrating. So we do have a possibility this vibration get transferred to other parts, and finally it will come to the cabin. Similarly, based on the road condition, the tire will get excited, and the vibration will transfer to the cabin. Similarly, improper balancing propeller shaft and the exhaust system can transfer the vibration to the cabin. So in this analysis, we are going to find out what is the exact cause, what is the exact system for the vibration. We will figure out and we will resolve it. Okay, so that's that's about transfer path analysis. Next, what is sound quality analysis? So here we are going to measure the sound noise parameters, okay, to find out what is the source, because of what source we are getting noise. Okay, in the vehicle, I can say that there are many sources which can produce noise, like engine, powertrain noise, wind noise, tire noise, and road noise. Okay, so we have to find out what is the exact source, which can cause the noise to the customer. So this is the study about sound quality analysis. Again, in sound quality analysis, we do have subjective method and objective method. The subjective method is purely based on jury's evaluation, just by hearing using our ears. And in objective evaluation, we use many microphones to acquire the data, requesting data, post process it, and we will come up with the result. And this is the LMS data loggers we used in NVH testing. As I told you before, the concept is going to be same, but based on your requirement, you can choose the system. Based on the number of channels and based on the field condition, you can choose the system. And finally, These are the subjects knowledge you should have to work with vehicle testing or automotive testing. So transducer engineering, electronics and instrumentation, electrical measurement and instrumentation, control systems, digital signal processing, mathematics, automotive engineering, and strength of materials. Okay. So now I'm going to, so this is the end of the session. So now I'm going to play you the video to explain how the strain gauge is installed. Yeah.
அந்த கிளாஸ் கொஞ்சம் எடுத்து குத்துருமா கையோட அதை க்ளீன் பண்ணி இந்த பெரிய இந்த அம்மா
So Yuvraj sir, shall we go for question answer?
Yeah, okay.
Thank you. Dear participants, if you have any question, you can ask our resource person now.
Sir, good morning, sir. This is Richie from Robotics and Automation SRC, sir.
Yes, Rishi, good morning.
Sir, actually, we are working on a project in the automotive industry regarding the safety features in
Okay.
the cars, sir.
Okay.
Sir, the main topic is about the automatic seatbelt ejection. I want to
Please come
ask
again. Automatic?
seatbelt ejection.
Seat belt, right?
Yes, the seatbelt ejection.
Seat belt ejection. So you're going to work with the buckle, right?
Yes, sir.
Okay, fine. Yeah, tell me.
What are the parameters or what are the systems we should be considering when it goes ahead for implication in the automatic industries, like in a car, sir, in a car company? What are the parameters we should consider?
So you mean to eject the buckle from the seat belt? You want to know what are the parameters we are going to consider?
Yes, sir. So
Actually,
what are
seat
the,
belt is not. Yeah, please.
so what are all the sensors we should use to make sure that the seatbelt ejection is connected all throughout the car?
So first you should understand what is the function of the seat belt. So as I know that in the seat belt we have webbing, right? Webbing is nothing but the what is that? What do you call the seat belt? The belt is called webbing, okay? And we have the reflector, I think. The name is reflector, where the webbing is going to wind it, okay? And we have the buckle and the lock. So lock is going to get locked with the buckle, right? So as since it's a different commodity, but let me try to explain you what I personally feel. What are the parameters you can measure? The first thing you want to measure the force. Okay, you want to know what is the force applied to release the buckle from the lock. Okay, so that is one parameter. The next one is so inside the buckle you have the lock, right? So both will get engaged. Once the buckle is engaged with the lock, so it's getting locked, right? So we want to measure the force of the buckle. The second thing is you want to know once the buckle is released, you have to confirm that whether it is released fully or partially. So if you ask me, I will use two sensors for this. Okay, one is a kind of load cell to measure the load, how much load is applied to release from the buckle. The second one is a kind of optical sensor to find out whether the buckle and the lock is completely released or not. Hello?
So yes, sir.
Yeah, that's it.
And when the buckle is released, we also thought of integrating it with the car system.
Buckle is released, car system.
Yes, sir. So for a particular scenario, when should a buckle be released? That was our project actually. So including that too, what are the sensors we should add with the car system too, sir?
Okay. So you want to know when the buckle has to release in case of vehicle is going to get met with accident. So you want to know when the buckle has to release, right?
Yes, sir.
Okay. So let me try to explain this. Okay. As I told you, we do have a reflector to roll the webbing, right? So in the reflector, we have a gear mechanism. Okay? We have many types of mechanism inside the reflector. So what it does is, so what is the concept of seatbelt? How the seatbelt works? Do you know that?
So as you said, there's a locking system which makes the buckle get inside and it gets locked. When a pressure is applied,
Yeah.
automatically the lock goes behind, which makes the buckle free.
Okay. So, the seat belt and driver airbag is directly proportional. Do you know that? So,
Yes, sir.
is the to save people life? Do you think that only just wearing the seat belt is enough?
Not actually, sir.
No, because seat belt and driver airbag is directly proportional. Okay? Once a vehicle has met with accident, within a millisecond, the driver airbag will deploy. Okay. So at that time, the people has to wear the seat belt. Okay. In case if you don't wear the seat belt, what will happen? You will go and hit with the steering wheel. So it will end up with loss of life. So the thing is, so driver airbag, once the driver airbag gets deployed, as I told you, everything happens in the milliseconds. So once inside the driver airbag, we have a part called reflector. I think I forgot that name exactly. We have a device inside that where the gas is filled. Okay. So once the vehicle is met with accident, the sensor will send the information to the reflector. So then the gas will comes out and it will go inside the cushion. That is cushion is nothing but the airbag, right? It will go inside the cushion. So once the gas goes inside the cushion, I can say for some fraction of time, it acts like a rock because we do have some small exact holes in the cushion. Okay, so in the fraction of second, all the gas will go inside the cushion, and some gas has to release it out. So once some gas released outside, so it will become the cushion. Before that, it act like a rock. So that's the reason you have to wear seat belt. So the seat belt will protect you. Seat belt will protect you before you hit with the airbag. Okay. So so you are going to work only with the seat belt, right? You're not going to work with the driver airbag.
No, sir.
Am I right?
Yes, sir.
Yeah. This is the concept behind that.
Thank you, sir. Then.
So I tried my best to explain this since this is not related to my commodity, but I know something how the seatbelt works and the driver airbag works. Okay?
Thank you, sir. Thank you so much.
Thank you. Thank you. Thank you. Any more questions?
Hello, sir.
Yes.
Sir. This is Madan
Hello.
from E&I.
Yes, I can hear you. Yes, Madan.
I'm from E&I department, SREC.
Yes, Madan, tell me.
So we know that nowadays automation is replacing manpower. So as an instrumentation engineer, what are the primary areas to be focused upon, sir?
Madan, as I explained to you before, I worked in automotive testing. Okay? So here, whatever field I worked is not related with automation. Okay? Automation, as I told you, automation is related with the automation is a different field. Okay? In my field, whatever instruments and sensors I used is just we are the users. Okay? We are not the developers. We are just the users. So just we are going to give the input to the developers. So developers will develop the instrument and sensors based on our requirement. Okay? So if you ask me, yes, of course, in the future, automation is going to replace the manpower. But I can say that it's not practically possible to replace 100%. Okay. So what in the production line, currently we use many manpower. Okay, just to transfer the subcomponents from one area to other area. Okay. So now what we are doing in our line production is we are going with automation. We are going with some robotic tools just to carry the subcomponents from one place to another place. But whatever field I told you, whatever field I have explained you, these fields cannot be replaced by machines. Okay. For these fields, we need people to test the vehicle.
Yes, sir.
Yeah.
Good morning, sir. This is Arvind. from A&I department as well as
Yes, sir. Good morning.
Sir, I have a doubt in data manipulation and DAC, sir. That will be a huge amount of data produced for every minute. How can you process all the data with the help of a DAC, sir?
Exactly. That's a DAX system does, You have many types of DAX system, okay? I think you have worked with the basic DAX system. But whatever DAX system I have shown here is, it's a high-speed data DAX system where you have a high memory capacity, okay? The second thing is, you can store the data directly in the laptop. As I told you before, we do have a dedicated data acquisition software. So the data can be directly stored in the laptop itself. So you don't want to store the data in the DAC, and again you don't want to transfer that to laptop. You can store the data directly in the laptop. So I think in the normal days we use 1 TB, 2 TB hard disk, right? So I think it's more than sufficient.
So we have
So
a laptop. After that only we have processing.
Yes. Exactly. Once we collected all the data in the laptop, we can move those data to the hard drive or the server, okay, where we can pull out the data in the future for further analysis. Okay, you know what is the cost of the data acquisition system I have shown? It comes around 60 to 70 lakhs based on the number of channels.
Yes, sir.
I'm saying just a starting price, it's very, yeah.
Yes, sir. But in on-road condition, there will be engine control, sir. But how can it be well performed manage all these data, sir?
Engine control unit is nothing but the ECU, right? That is different. Engine control unit normally, the previous year, engine is purely mechanical device, right? Now it's I can say 80% of engine is controlled by the electronics, right? So we have an ECU, electronic control unit, to control the engine. So that is different from this, okay? So that ECU comes with the vehicle, and we do have many ECUs in the vehicle. There's one ECU can control the engine, other ECU can control the steering column, and other one for drive system. It depends. But whatever testing I have explained you is not related to ECU. So we are going to install the sensor. Okay, we are going to install the sensor, and we are going to collect the data using the sensor. Maybe we have OBD connector. Maybe just for cross check, we can pull out some data from vehicle ECU just for our cross check. Okay, all the sensors which comes from ECU is a digital signal. Okay, so we have option in the data logger where you can collect some sensors from ECU so that you can use it for post processing. But whatever sensors I have explained is not related with vehicle. We are going to fix the sensors externally. We are going to get the data accordingly.
Okay, thank you.
Yeah, thank you.
So, Yuvraj sir, myself Kaushik, I have one doubt.
Yes, boss.
What are the fundamental components you have to go through when you're measuring a signal? Apart from a simple magnitude and frequency, what are the other things you will usually go through the signal?
You mean the specification, right? So what are the parameters we have to feed in the configuration, right?
No, from the signal, what are the signal components you will measure apart from magnitude and frequency?
Oh, that is going to be the common, boss. So magnitude and frequency is going to be common. Okay. So in the DAC system, what we're going to do is we are going to collect the raw data. It's a time domain data, right? Okay. It's a time domain data. Say, for example, if you want to measure the data in the engine, so you want to measure the vibration data in the injector. Let's take example like this. Okay. So I'm going to mount the accelerometer near to the injector. Okay. So whatever data which I'm going to collect from the sensor is a time domain data. Okay? Time versus amplitude. So, but important thing is that is a raw data. We used to call it as a raw data because it's a combination of many signals. Okay. So in the post processing, whatever data you collect in data acquisition is a raw data. So once the raw data is collected, we have to move those data to data analysis software to find out your requirement. to make sure what is your requirement. Okay. Say, for example, if you want to find out what are the frequencies placed in that. So we need to go for FFT analysis to find out what are the frequencies acting there. Okay. And from that, so as I told you, we are going to measure the vibration in the injector, right? But whatever data you collected is a combination of all the signals. Okay. In engine, you have many vibrations. So whatever data is you are collected is a combination of many signals. So as I told you before, we do have some natural frequency, right? Each and every part have the natural frequency. By keeping that as a reference, you need to segregate the data. You have to filter the data, okay? You have to convert the time domain to frequency domain to find out what are the frequencies placed in the data. So accordingly, you have to do measurement and testing. Yeah.
Okay. So first you have to definitely go through the natural frequency of the every measuring object, and then you have to filter out based on that, right?
Exactly. Yeah.
Oh, thank you.
Yeah.
Hello, sir.
Hello.
Sir, I'm Swati from E&I department.
Yes, Shanti.
Okay. So we are doing a project in automobiles, which is based on implementing black box in automobiles.
Okay.
Okay. As e-vehicles are being in research, what are the main features you think should be included in our black box so that it could sustain even after 10 years in future?
Whatever concept you have chosen, it's very complex here.
Yes.
Black box can be designed, can be implemented in the craft. But to be honest, I don't say right now what are the parameters we can collect in a black box for vehicle, because vehicle is subjected to many vibration and noises, right? Say for example, when the vehicle is going to get accident,
Yes,
many
sir.
vibration and sorry.
Yes, yes, sir.
Yes, it's subjected to vibration and sudden impact, right? So at that time, each and every part of the vehicle component will behave differently. So here, I need some time to think about this here. I need some time. Maybe I can come back to you through email. Okay, just give me some time, because it's too early to answer this question. Let me think, because this concept is completely new for automotive. So we have many complex just by inventing a black box device in automotive. Yeah. So just give me some time. I can come back to you. Yeah.
Okay, sir. Sure, sir. Thank you.
Thank you.
Kaushik?
Yes, sir. We can wind up, sir.
Yeah. Thank you, Mr. Yuvraj, for giving a nice talk on instrumentation role in automotive testing. And you have given an idea of the selection of instruments and sensors used in testing. And also you covered types of vehicle testing and also the NVH testing also. Really, it was a wonderful session. Thank you, Mr. Yuvraj Tandapani. Also, I thank the faculty members of the department for organizing this webinar a grand success. And my special thanks to Mr. S. Kaushik, Assistant Professor of the department, for conducting the entire process. Thank you, Kaushik.
Thank you, sir.
Also, I thank all the participants who are involved in active participation in this 4th week of webinar conducted by the Department of Electronics and Instrumentation Engineering. And we will meet you the last week of webinar series on next Saturday with the resource person, Dr. NIT Calicut Karthikeyan, Dr. Karthikeyan, Professor NIT Calicut. Thank you all.
Thank you, sir.